light. You know, in 11th class we have studied Doppler's effect in case of sound. We are studying today Doppler's effect in case of light. So according to Doppler's effect, whenever there is relative motion between the source of light and the observer, relative motion between the two, the apparent frequency received by the observer is different from the actual frequency emitted by the source of light. Suppose this is a source of light and here is an observer. If there is relative motion between the two, then the apparent frequency of light received by this observer is different from the actual frequency of light emitted by the source. That is known as Doppler's effect. And you know, whenever the distance between the source and observer, source of light and observer, whenever the distance between the two is decreasing, the apparent frequency of light emitted by the source, or we can say apparent frequency of light, increases. But when the relative distance, or when the distance between the two is increasing, in that case apparent frequency will be decreased or apparent frequency will decrease. So apparent frequency will increase when the distance between source and observer is decreasing, and apparent frequency of light emitted by the source of light will decrease when the distance between source and the observer is decreasing. Now suppose there is a source of light and the light waves emitted by the source has wavelength lambda. Suppose we have a source of light that is emitting the light waves of wavelength lambda, frequency nu, and these light waves are traveling through vacuum with speed of light c. You know all these terms. This is wavelength, this is frequency, and this is the speed of light waves emitted by the source of light in medium. So light waves emitted by the source are traveling in vacuum with speed c. And you know, you have learned a relation lambda is equal to c by mu. You are well aware about this relation. Let us write over here. Lambda is equal to c by mu. Mu is the frequency of the light waves emitted by the source of light. Now let us, and we know, suppose the source and the observer are approaching towards each other along the propagation of light waves, and the source and the observer will come close by a distance, suppose v. V is the velocity of the light, and the two are, source and the observer are coming close to each other by a distance v. And you know, the apparent frequency when source and the observer are approaching each other, in that case the apparent frequency of light is denoted by nu dash, and this apparent frequency is given as number of light waves emitted by the source of light per second, and this can be written as, this apparent frequency can be written as nu plus v by lambda. V is speed of light and lambda is wavelength. This apparent frequency is equal to the frequency of light rays, or we can say number of light waves emitted by the source per second plus number of light waves contained in distance v. So this is apparent frequency, and we know from here lambda can be replaced by C by V. Sorry, C by nu. So V dash, or sorry, nu dash would become nu plus, this is V, please keep in mind, and lambda can be replaced by C by nu. And we can write it as nu dash is equal to nu plus V nu by C. We can take nu common and it would become nu into 1 plus V by C. And you can see over here clearly nu dash is greater than nu. That means apparent frequency is greater than actual frequency of light waves emitted by the source of light, or we can say light waves received by the observer. And this is the case when source and observer are approaching towards each other, or we can say when the distance between the source and the observer is decreasing. In that case, apparent frequency is greater than actual frequency. So this is first case, nu dash is equal to nu into 1 plus V by C. This is one case, or first case, when source and observer are approaching towards each other, the distance between source and observer is decreasing. In that case, apparent frequency is greater than actual frequency. Now let us consider the second case, when the distance between the source and observer is increasing. In that case, the apparent frequency would be given as nu dash is equal to nu into 1 minus V by C. And this is second equation. By combining the two equations, by combining first and second, we will get nu dash is equal to nu into 1. Here is plus sign when the distance between the two is decreasing, and minus sign when the distance between the two is increasing. So it would become 1 plus minus V by C. And we can modify this equation as nu dash, we can take it in its denominator, nu is equal to 1 plus minus V by C, and it can be written as 1 minus V square by C square. We can calculate from over here. Apparent frequency we have already derived in case of when the distance between source and observer is decreasing, and when the distance between the source and the observer is increasing. Now we have to find out the velocity of star. We can calculate one more thing. Velocity of calculation. This was the calculation for apparent frequency. Now calculation for velocity of star. कैसे हम velocity of star find out करेंगे? देखो, you know, अभी हमने निकाला apparent frequency is given as nu dash is equal to nu into, इन दोनों को कंबाइन करेंगे तो it would become 1 plus minus V by C. इसको लिख सकते हैं ऐसे. अब आप इसको अंदर मल्टीप्लाई कर लीजिए. इट वुड बिकम nu dash is equal to nu plus minus nu V by C. I hope this is clear. Take nu to this side. Nu dash minus nu is equal to nu V by C. I hope I'm clear. This can be written as change in frequency, and change in frequency can be denoted by delta nu, and this is equal to nu V by C. I hope I'm clear. Let us write this result over here because we will use it later on. Delta nu is equal to, sorry, this is containing plus minus sign, plus minus nu V by C. Now from over here we can take out the value of V. So delta nu c over this is v equal to plus minus, ये यहाँ पे क्रॉस मल्टीप्लाई हो जाएगा तो डेल्टा न्यू इंटू सी ओवर न्यू एंड दिस इज वेलोसिटी। आप इसको यहीं पे स्टॉप कर सकते हैं। दिस इज द वेलोसिटी ऑफ द स्टार। आप चाहे तो एक दो स्टेप इसमें और भी कर सकते हैं, वो कैसे देखो। आपको पता है दिस इज द वैल्यू ऑफ v। You know lambda is given as c by nu, and from here, from this equation we can find out the value of nu. Nu would become c by lambda. Nu is equal to c by lambda. I hope I'm clear. From this result I can write down the value of frequency, that is nu equal to c by lambda. Now I will differentiate this equation with respect to lambda. So on differentiating with respect to lambda, you would get d nu by d lambda is equal to, इसको आपको पता है डिफरेंशिएशन करना है, इसका डिफरेंशिएशन करोगे it would be c by lambda square. I hope I'm clear. From here we can find out the value of d lambda. D lambda would become, यहाँ से क्रॉस मल्टीप्लाई हो जाएगा एंड इट वुड बिकम माइनस लैम्डा स्क्वायर डी न्यू बाय सी एंड वी कैन चेंज डी लैम्डा बाय डेल्टा लैम्डा एंड दिस इज इक्वल टू माइनस लैम्डा स्क्वायर बाय सी, और इसको हम लिख देंगे डेल्टा न्यू। आई होप आई एम क्लियर। Replace the value of delta nu from here in this equation. So it would become delta lambda is equal to minus lambda square by c into plus minus nu v by c. And from this equation we can write down the value of c as lambda into nu. So we can replace this c is equal to lambda nu. So it would become lambda nu. Nu से nu आपका कैंसिल आउट हो जाएगा, lambda से 1 lambda कैंसिल आउट हो जाएगा and we would get delta lambda is equal to minus plus and this is equal to lambda v by c. This is equal to delta lambda. From here also you can find out the value of v. V would be equal to the delta lambda c minus plus over this is lambda. Now you have to understand two terms, blue shift and red shift. One term is blue shift. ब्लू शिफ्ट कब होगा एंड रेड शिफ्ट कब होगा? ब्लू शिफ्ट होगा when source and observer are approaching towards each other, or we can say when the distance between source and observer are the distance between source and observer is decreasing. That means they are coming close to each other, or the distance between the source of light and the observer is decreasing. In that case the value of apparent frequency would increase, and you know if apparent frequency will increase, in that case apparent wavelength would decrease, and that is known as blue shift. That means यहाँ पे जो आपके पास डेल्टा v आया, जो आपने यहाँ से लिखा था डेल्टा v, अगर इस डेल्टा v की वैल्यू अगर पॉजिटिव आती है, दैट इज द केस फॉर ब्लू शिफ्ट. एंड रेड शिफ्ट कब होगा? व्हेन द डिस्टेंस बिटवीन द सोर्स ऑफ लाइट एंड द ऑब्जर्वर इज इंक्रीजिंग. इन दैट केस अपरेंट फ्रीक्वेंसी विल डिक्रीज, और फ्रीक्वेंसी अगर डिक्रीज करेगी, अपरेंट फ्रीक्वेंसी अगर डिक्रीज करेगी तो अपरेंट वेवलेंथ वुड इंक्रीज, एंड दैट इज नोन एज रेड शिफ्ट. एंड हियर delta v is negative. So this is all about the Doppler's effect in light. In the next video we will start the concept of polarization.